Hey, how's it going, guys? In this tutorial, we're going to learn how to fit multiple graphs into a single window in PyQt5. Alright, so this is going to be what I consider as an advanced tutorial. So before diving into the tutorial, make sure that you have some experience writing PyQt application. Now let's take a look at some of the features built into this application. So from this application, I have a window. So this is going to be the main window. And inside the main window, I have 9 windows. And each window contains a matplotlib graph. And one of the main features we're going to implement in this application is we'll be able to drag different windows to different places or different location. So let's say I want to drag chart number 1 to swap with chart number 8. So I'm going to place chart number 1 on top of chart number 8. Now we can see that chart number 1 and chart number 8 now is swapped. And this is pretty handy if you want to reorganize your chart sequence into a more logical sequence. Alright, so that's basically all the demos that I'm going to show you. Now let's dive into the tutorial to see how we can create an application like this. Alright, so I'm going to start by importing the libraries first. I'm going to import the system module, render module, and from the PyQt5.qt widgets module, I'll import QApplication class, QWidget, QScroll area, QFrame, QGrid layout, and QFeedbox layout. So those are the classes that I'm going to import from the Qt widgets module. And from the Qt core module, I'm going to import Qt class, QEvent, and QMyData. And to implement the drag and drop effect from Qt GUI module, I'm going to import the QDrag class. Alright, so since we're going to integrate this application with matplotlib, from matplotlib.figure, I'm going to import figure class. And to insert matplotlib graph to PyQt5 application, from matplotlib.backends.backend underscore qt5 agg. And from this module, I'm going to import figure canvas qt, it should be uppercase T, agg. So that's the class name. And I'm going to rename the class as figure canvas. Alright, so here let me create my application class. I'm going to call this my app. I'm going to pass QWidget class as the parent class. Alright, so here's my initial setup. Alright, so here I'm going to insert my name routine. If name is equals to main, then I'm going to construct my QApplication instance. And for the argument, I'm going to pass system argument. And here I'm going to insert a try except block. I want to check against the system exception. Basically, every time we close the window, the system exception is going to occur. And I just want to print a message. App is closing. And inside the try block, I need to terminate the application operation. Alright, so let's create my app class instance. I'm going to name the object my app. Alright, so this is going to be my my shell or my base. Alright, so let's start by inserting a window title. And I'm going to name the window title multiple graphs in a single window. Next, I'm going to set the window minimum dimension. Let's do 2000 for the window width and 1400 for the window height. And because we want to perform the drag and drop function or feature, I need to set the set drops setting to true. Now let's create our first widget, which is the scroll area widget. I'll name the object self.scroll area is equals to QScroll area. And here I forgot the R. And from the scroll area object, I want to set the set widget resizable setting to true. So this will simplify the operation. When we expand the window, we don't need to write the code to how we want to resize other widgets individually. By fitting all the widgets or windows into the scroll area widget, the scroll area widget will handle the resize feature for us automatically. And this is going to be the main layout object. For the main layout object, I'm going to use vertical box layout. And I need to specify the main layout belongs to the myApp class. Alright, so at this point, if you are new to PyQt5, this may be a little bit confusing. Here I'm going to create a container to hold all the windows that contains the graph. So I'm going to call this one. Let's do graph window container. And I'll name the object graph container. And it's going to be a QWidget object. Next, I need to create a layout to hold all the windows that contains the graphs. I'm going to name this layout self.grid layout. And it's going to be a QGrid layout object. Oh, and here we need to provide the parent. And the parent is going to be self.graph container. Now I'm going to reference the self.scroll area object. I need to set the widget that the scroll area is going to use with self.graph container. So just think this widget as my window container to hold all the sub-windows. Then I can add the scroll area to my main layout object. Now let me launch the window to see if I have any typo. Oh, I forgot to activate my environment. And this should be matplotlib. And this should be self.scroll area. Now I have my base area. So you see this rectangle or square inside the main window. So this is going to be the area that I'm going to be using to insert my windows to hold different graphs. Alright, now let's create the method to insert the graphs. I'm going to name this method create graphs. I'm going to create a variable called tracker, and it's going to be used to identify the window number or window index. And I want to insert 3 windows per row and per column. So here I'm going to insert next loop. I'm going to say that for I in range, and I'm going to insert 3 rows and 3 columns. Actually, this should be row and this should be column. So let's call this C for C in range 3 and for R in range 3. Inside the loop, I want to create a frame object to hold the windows. And the reason being is because we can customize the Windows background. And here I'm going to insert the setStyleSheet method. And I want to change the background color to white. Next, I can set the frame style. Let's do frame.panel. I also want to set the frame style to raised. Now I need to create another layout object to hold the frame. Let's name this object frame container. I'm going to use QWidget layout to hold the frame object. And here let's create the chart data. And because I want to create nice sets of charts, so I'm going to insert a loop for I in range. And I want to insert 9 to create nice sets of data set. And for the data points, I'm going to use random function to generate the data points. And I'm going to increase tracker's value by 1. Now let's create the map-per-love graph. And we need to start by, here let me insert nodes, create map-per-love graph. And we need to start by creating the figure. And from map-per-love's library, there's already a class called figure canvas. And this is basically the PyQt5 to hold the graphs. And I'll name the output as canvas. So I'm going to insert nodes, PyQt5 widget. Now let's create our axis object. And I want to add my graph to the map-per-love figure. And I'll type figure.addSubplot. And once I have my x object, I can insert the data point by referencing the plot method. I'll insert the chart data object. And for the graph, I'm going to insert a line graph. And to easily identify the graph, I want to insert chart title to each window or to each graph. So here we can type figure.subtitle. And I want to type chart number followed by the tracker number. And I can draw the chart by typing canvas.draw. And to implement the drag and drop feature, here I need to combine the two this later. So here let me insert to-do list, drag and drop feature. Now I want to add the figure to my frame container object. .addWidget. I'm going to insert the canvas object. And here I forgot to assign frame object as the parent. Alright, so let's see. Alright, so the next step is, here let me show you something. So here let's say I want to insert, let's see. So if I want to insert my graph directly to the frame container layout object. So here let me reference the grid layout. .add layout. I'll insert the frame container object followed by the row index and the column index. Oops. Now going back to the constructor, I want to call the create graphs method at the end. Now let me launch the application. And here, let's see, this should be random. Oh, I forgot to provide the parent. And no subtitle attribute. Oh, this should be subtitle, not sub. Alright, so if I attempt to insert the frame container layout directly to the self.gray layer object, we're going to get this error message. The layer object already has a parent. And the workaround is we'll create another layer object to hold the frame container. Alright, so let's call this box. And from the box object, I'm going to add the frame widget to the box layout. And since I'm only adding the widget, I'm not using frame object as the parent widget, so this is going to be okay. I'm going to replace frame container with box. Now let's take a look. We now have the 9 windows that contains each graph individually. I want to set the window size ratio evenly. And this is something extra. So from self.gray layout, I'm going to insert the set column stretch method. I want to insert the R value, and I'll divide the number by 3. And this will give me the remainder. And I want to set the stretch value to 1. And I'll do the same thing to the set row stretch method. And here I can simply insert the, this should be R, this should be C. Let me take a look. Okay, so that looks pretty good. Now we have finished create graphs method. So this is everything we need to write to create this function. We need to go back to the top. Oh, here we need to go back to the to-do list. We're going to install the event filter to the canvas object. We can type canvas.install event filter. And make sure that you insert self to reference to the parent object. And there are multiple events that we need to handle, but here let me create a function called getWindowIndex. And this function is going to be used to get the, here let me launch the application first. So for these 9 windows, each window has a index number assigned to it. So this is going to be index 0, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to use the index number to reference to each window individually. And this function is going to help us to insert the mouse coordinate to return the window index number. Alright, so here I'm going to insert a loop for I in range. And we're going to grab the window count from the self.gray layer object.count. And I want to insert if statement, if self.gray layer.item@. I'm going to insert the index from 0 to 9 until the geometry contains the position coordinate from the position argument. So I can type if self.gray layer.item@ followed by the window index that we're going to check .geometry.contains. And I'm going to insert the coordinate value. If this statement returns true, then I know that's the window index that I'm currently selecting. So I'm going to return the index number. For the next item I'm going to do, I want to implement my event filter. And from the event filter method, we're going to pass the widget I'm going to name the widget argument or the widget parameter as object and event. And there are two events that I want to handle. Let me get the event type. The first event I want to handle is the mouse button plus event. And the second event I want to handle is the mouse move event. And we need to make sure that we return the event state. Now let's handle the mouse button plus event. So let me insert the event name, mouse button plus, actually it should be mouse plus event. Inside the mouse plus event, I want to insert if statement if event button is equals to left button. Then I want to grab the corner value. I can reference the event argument, the window position, the 2 point. So this will convert the value to Q point object. And here I can insert the get window index method. I'll pass the corner to get the window index. And let's call this self.target index. Otherwise, I'm going to set the target index to none. The next event I want to handle is the mouse move event. Basically, every time when we use our mouse to do something, the mouse press event is going to fire first. Then it's going to move on to the mouse move event. Inside the mouse move event method, I want to insert an if statement. I want to say that if events.buttons is equals to qt.left button. Alright, so here I want to say that if event.buttons is equals to qt.left button, and if self.target index is none, then I want to grab the window item. The window item is basically the window widget. And I can reference the self.gray layer object, the item it. And I'll insert the window widget index number. And to perform the drag and drop effect, we need to create a QDrag object. And I'm going to pass the widget object that want to perform the drag and drop. Now let me put the window back. When you perform the drag and drop, here let me drag this window. We want to create this animation. And to do that, we can create a set of motion images. So from window item object, within the window widget, we need to reference the first item or the first widget underneath this widget. So we need to reference item at method again. And we're going to insert 0 to reference the base widget, that graph. And it's going to return as a QPixMap object. I'll name the output as Pix. Now I need to convert the Pix object to a MyData object. And I can do that using the QMyData class. And from MyData, the set image data, and I'll provide the Pix object. I'll reference the drag object, the set MyData. And insert the MyData object. Then I need to specify the PixMap object and this should be pics, followed by we need to set the hotspot. And it's going to be coming from the event position argument. Then we need to execute the operation. Now let me take this method. I will assign that to the event filter under the mouse button plus event. And we need to insert the event argument. Alright, now let's give it a try. Alright, so here I already have a typo. Self.target index. Let's see. Oh, this should be mouse plus event, not move event. And this should be mouse move event. Now let me try again. Okay, so here it's not getting the QWidget object. Oh, this should be a method. Let me try again. Okay, so now we now have the dragging animation. For the next step, we need to implement the drag and drop events. Because currently we're only handling the mouse related events. We're not actually implementing what happened when we let go of the mouse button. Alright, so here let's do that right now. We're going to implement two more events. The first event is going to be the drag enter event. And the next event is going to be the drop event. So the sequence is going to look like this. We are going to select a window. So that's when the mouse plus event is going to fire. Then we're going to move the window to somewhere else. And that's when the mouse move event is going to fire. And because we actually need to drag the window to a different position or to a different location, we need to also implement this drag enter event. And when we let go of the mouse, then the drop event is going to fire. Then it's going to swap the windows. Alright, so let's do the drag enter event first. So for the drag enter event, I'm going to check if event.myData has image. Basically, we're checking against the QWidget object. And if this statement returns true, they want to accept the event. Otherwise, we're going to ignore the event. Then we need to implement the drop event to swap the windows. And I'm going to say that if not, event.source.geometry that contains. And I want to check against the event position. And here I want to check the select window index. So I'm going to insert the self.get window index function. I'm going to insert the mouse corner. I'll name the output as target window index. And I want to check if target window index is none. Then I just want to X out the function. Otherwise, I want to return the window indexes. And here I want to insert the max function and the min function to always return the window index in such order that every time when we do the swapping, no duplicate sequence is going to occur. Alright, so here from the max function, I want to grab the max value between self.target index and target window index. And same thing with the main function. And I'll name the output as INJ. Now I need to get the widget position associated to the window index of INJ from the self.grid layout. Alright, so here I'm going to insert the self.grid layout object that gets item position. I'm going to insert the widget index number, and it's going to return as a tuple, followed by the widget position information, such as the row index number, column index number, and the width size and column size. And I need to do that for INJ. And I'll name the output as P1 and P2, position 1, position 2. Now I need to swap the widgets, so I can insert self.gridLayout.add item. And I'm basically taking the insert the widget index that I want to reference. And this one's going to be I, and this one's going to be J. And because the add item method does not take a tuple, we need to convert the tuple as regular values. We can do that by insert wildcard symbol followed by the tuple object. And this should be P1 and P2. Alright, I think this is everything we need to write to complete this application. Let me just do a test run. I'm going to swap chart number 1 with chart number 9. And I see that chart number 1 is missing. Here, let me take a look. So here this should be J, not I. Otherwise, we're basically swapping the same window. Now let me try again. Now if I swap chart number 1 with chart number 9, let me try again. It's not working. I think the mistake is here. This should be P2 and P1 because we're trying to swap the window. So the sequence should be reversed. Let me try again. Now if I try to drag chart number 1 with chart number 9, and this time it worked. So if I try to do chart 7 with chart 4 and back, and I can confirm that I'm able to reorder the charts or windows successfully. So this is everything I'm going to cover in this tutorial, and hopefully you guys found this video useful. And as always, thank you guys for watching. I'll see you guys on the next video.